Hey everyone. Thank you for coming on this, I think it's like the perfect slot for this conference. It's the first day, so I'm not too hungover. It's in the afternoon, so I'd have like my maximum caffeine intake, and I'm just gonna be coasting for the rest of the day. So I feel pretty good about things. So my name is Jimmy Bogard. You can find me on Twitter at @jbogard. Word of the warning, you may wanna mute Untapped. If you follow me, you'll see quite a few of those tweets coming up. You can find me on GitHub, conveniently also at github.com/jbogard. And that's also where you find the presentation here, as well as any kind of code and things like that. You can find that at GitHub. I blog about this subject, as well as a lot of others, on my website at jimmybogard.com. And for my day job, I actually work for a company called Headspring out of Austin, Texas. It was a very long ride on my horse on the way here, so he's very tired. And for my day job, I do consulting for companies where I build custom complex systems. And so a lot of things we'll be talking about are really just a lot of lessons learned from implementing this kind of architecture over the past, 6 or 7 years or so. And that's some other junk about me. I do a lot of open source stuff. And I think I get an award for doing that. I don't really know why I get it, but I don't say no. I get free stuff, so hooray, free stuff. I've enjoyed my time in Australia so far. There's a few things that I would improve, though. I have yet to have a single Tim Tam Slam, which I think I need to fix that pretty soon. And also, there's no Starbucks. What's going on, guys? Get your coffee stuff together, please. All right, so let's talk a little bit about vertical slice architecture. So I've done a few talks in this area over the years. It's really talking about some of our journey from the previous kinds of systems we were working with and this kind of architecture. So this talk is really about looking at us doing this kind of architecture for the past 6 or 7 years and talking about some of the lessons learned and patterns we've seen while working in this kind of architecture. So first, I want to do a little bit of a history lesson. Let me switch over here. There you go. A little bit of a history lesson. This is, of course, the Battle of Waterloo. So a very large part of my career, I was actually Napoleon, in which I marched all the way to Russia, lost almost all my army, and came all the way back, and then was defeated. And then for the rest of my career, I was the other guy, the Duke of Wellington, I think. I don't know. We don't really get much history outside of Texas. Like, we were a country, so. Anyway, so a little bit of a history lesson that led us up to the vertical slice architecture that we're doing today. And it really all started with us doing a lot of traditional interior style architectures. And for the most of my career, this was kind of the way to build systems and to build applications. So a lot of the documentation from Microsoft when they were first getting started with .NET really recommended to build applications and architectures like this, where I have a very kind of very segmented, heavily layered kind of architecture, where I have a user interface layer. They can only talk to the business logic layer. The business logic layer is supposed to be isolated, so it doesn't really do anything else. It only has abstractions it talks to, not any real dependencies. And of course, we have to have the data access layer and the database. We improved upon this model, of course, with domain-driven design. So now we had a domain layer and repository, but is basically a similar kind of traditional interior architecture for most of my career. So in these kinds of architectures, a lot of the code we had was then organized by those individual layers. So if I had something in my system that was dealing with like a person or order or an invoice or something like that, we'd have different objects related to the different things that you'd want to do with that specific object. So we'd have things like a person object, of course, and the person object contained the data and probably not any behavior, but mostly just data associated with that object. For the user interface part, we'd have the person controller. So that was where the main web request came in for you to interact with this thing. For all the business logic, of course, we don't want to put that in the user interface layer. So we moved all the business logic into service classes. And inevitably, those service classes were then named after the main entity or object they were related to. So for this, that meant we had a person service. That service had to do some kind of data access, whether it was queries to go ahead and build out a list of people or something like that, or to get individual parts. So we had to put that inside of a person repository. And so we had to be very strict about the kinds of logic we put in each of these places. But one of the things we found was that these became sort of dumping grounds for all the kinds of logic in our system. So anything dealing with a person in terms of business logic all got dumped into that service class. Anything dealing with data access, again, got dumped in the person repository. So those classes and types grew and grew and grew over time until at one point we looked back and said, I don't think we're doing this right, because we keep going down this layered architecture, and all it's doing is giving it larger and larger objects that just makes merging harder and harder and harder, because more than one person would be editing the service class, and we check in, and then someone would change this part and this part, and we get this conflict of like, oh, we're all thrashing over these very common objects and these very common layers. Whenever I needed to change the system, I noticed I was jumping around the code base quite a lot. In our code base, we would organize all these objects by layer. So we'd have folders for each of the kinds of layers in our system. So we had a folder for controllers, a folder for services, a folder for repositories. This is a simplified view. We had a vegetable-based architecture. I think you know what I'm talking about. If you bite it, you start to cry. We certainly cried a lot with the onion-based architecture we had for so long. And each of these folders was actually pulled out into separate projects. So the project structure became pretty complicated as well. So whenever we wanted to make a change to the system, we had to go to all these different locations to just do something like add a new field to the screen. So if we wanted to add a new field, well, of course, we had to go to the controllers to be able to say this new object needs to have this new set of properties there. We needed to change any kind of services or handlers associated with it, so we had to go to that folder as well. We had to change how that information was displayed on the screen, so we had to change the view models associated with it and the view models folder. And then finally, we had to, of course, go to the views folder to actually change how the things were displayed. So we found ourselves jumping around a whole lot, and it made it really difficult to understand. When I made a change, all the different things that I need to touch, because everything was spread out according to the kind of thing it was, as opposed to bringing everything together when it needed to change together. So part of this project, we threw out all those notions of any kind of layered architecture and moved towards what I called vertical slices. I wish I had a more clever name than this, so maybe afterwards someone can like trademark something better than this, but this is about the best thing I can come up with, is dealing with code in vertical slices. And the way we look at this is, instead of thinking about all of our code in the kind bucket, so it's saying all the service kind of code belongs in a service, all the repository kind of code belongs in a repository, and instead looking at, when I need to make a change to the system, everything I need to touch in order to make that change, why don't we put all that code in one spot? So that was the very first thing we did when we built this kind of vertical slice architecture. We looked at making a new change to the system, and we literally wrote it on the whiteboard that says, I have to change this class, I have to change this task in this class. How can I take all that code that is very much related to each other and pull it all together into one spot? So that when I have to reason about a feature or understand how the system behaves for a specific action or task the user is performing, I can just go to one spot to see all the code related to that change. Now, the way we did this was a lot of refactoring. So thankfully, we all had ReSharper licenses, because Visual Studio at the time didn't have anything, but I guess you can just use that today. JetBrains isn't sponsoring, so I think you can say you can use Visual Studio, right? Yeah. So I moved all the code related to a change as close together as possible, sometimes in the exact same file. I went to those original layer classes. I'd have something like some kind of noun-based service, and that service had different methods for the different kinds of things you would do with that, for that domain object. And I moved all those individual methods into individual classes for each of the kinds of things it would do. So if I could approve, reject, or flag an invoice, instead of having one class that had every single kind of thing you would do with that thing in one single file, I moved each of the different operations that would never be executed with each other into their own individual classes. So when I changed, for example, the approve function, I didn't have to worry about the side effects with rejecting or flagging an invoice, because all the code related to that kind of operation was separated out from all the other different pieces. Now, this did result in like way more classes in my system. So If you like to have fewer classes, then this is definitely not the architecture for you. If you like to have things very much organized and separate from each other so you don't have to worry about anything messing with each other, then this is what we found worked really well for us. So this is our first step, was just taking all of those individual methods and moving them to separate classes. Then we looked at each class and said, you know what, these all look similar but not quite the same. They all look like they're just performing one action. So they're just doing an approval, they're doing a rejection, or doing a flagging. And there's some kind of like input to the thing. It does the work, and then there's some kind of output. So we started explicitly modeling our classes to represent that kind of abstraction. So instead of representing our abstractions in terms of like services and repositories, instead we had a request to do something, then the work itself, and then finally whatever the output of that thing was. So it looked something like this. Everything in our system had some kind of input, then some kind of handler that would handle that request to do the work, and then sometimes that work to be done would have some kind of output. So over the course of like 2 or 3 years, I did this pattern in several projects, and it got to the point where I was just copying the same code over and over again. And even though I do a lot of open source, I don't really enjoy doing it. It's not that fun to get all these Stack Overflow questions of people complaining about your stuff. So I eventually said, OK, fine. I'll create an open source library that I don't have to keep copying this code over and over again. And so I pulled that code out that represented this kind of pattern of requests, handlers, and responses into a full-fledged library. And this library is called Mediatr, or Mediatr. I don't know how to pronounce it right, even though I named the thing. I should probably get that sorted out. Now, of course, if you notice the name, I made it around the time SignalR came out. And I'm not that clever with names, so that's why it's called Mediatr. And it's also very Googleable, so that's good. I always want that. Anyway, so what I did was I took all those disparate request objects that I just each time made up on my own and said, let's just represent those requests as a first-class citizen in our application. And so each request is now represented by some class that implements this interface, iRequest of T. Now that T actually represents the response type. So every request is inherently coupled to the response that it will produce. And in the middle, to get from that request type to the response type, is the magic handler that just is like the stupidest interface possible, which is take a request and return a response. Very exciting stuff, right? Of course, we're all async, await stuff, right? So now instead of just returning T, I have to return task of T. Unfortunately, it's everywhere, right? Everything we have to do is task-oriented. So anyway, now it has a task of T as its return, just in case I need to do async stuff. So everything in my system now revolves around these individual requests, the handler to do the work, and then finally whatever response comes out the other side. Now registering all my handlers is pretty straightforward. This is ASP.NET Core dependency injection junk. So I try to make it as easy as possible to add this to my systems. So down there you could have, there's a line that says services.addMediator, and you tell it where to look for your handlers, and it knows how to register all of them. So I just want to make it as easy as possible to add this to my applications. So everything in my system was revolved around these requests. But it got a little bit more subtle than that in the types of requests I'd have in my system. And I found that most of my systems, actually all of them, had different kinds of requests. I typically build web applications, whether it's server-side web applications, MVC, kind of traditional server-side rendered MVC, or even like single-page applications or just pure web APIs. All those applications basically revolve around gets and posts. I know there are more exotic like HTTP methods than post, but I'd say 99% of the time, the systems I build either get information out or I'm trying to change something. And so those can be represented as requests to either get data in the form of a query or to change something in the form of a post. So my gets then represented queries, and those queries were kind of requests, where the request was a query, there'd be some kind of handler to do whatever work was necessary, and finally that would return the response, and that response was the data that you were interested in. The post represented the commands. That is, I want to change something in the system. And then these also had a similar kind of structure in that the commands now were the requests. They would have some kind of handler to handle that request to change some information. And then finally, of course, we'd have that response. Now, one of the big things I wanted to make sure when I did this was to encapsulate everything necessary to perform that action, that is, the handlers themselves. I wanted to have everything that it needed to do to be represented inside of those query and command objects. So I had this very simplified view of the world. And I like simple. I'm not, I used to like complex things and to do also, I like to keep things very simple now. And the simplest thing I can think of was I have one object going in, something does the work, and then one object coming out. There's not like all these weird context things where I can reach out to do other stuff. Nope, just like everything that you need to do the work must be passed in through that request object, and then everything that you need to worry about on the other side is passed out through the response object. There's no other kind of indirect inputs or outputs. So we then took this another step further. So this is just talking about the main meat of the work in this middle handler. We started to move everything related to be able to handle that request into that single class that represented everything to do. So we had more or less complete encapsulation of how that work needed to be done, so that when the request came in, it was basically a black box. I didn't know what the internals were doing. It would do all the work, and then finally, out coming the other side was a response. And as much as possible, we tried to push all the behavior inside of these handlers so that I had one spot to go to understand what was all the logic necessary to be able to fulfill those requests. So in our systems, we had, again, queries and commands. Modeling the queries started with that initial request object up front. Now, some of our queries were very, very simple. That is, it was just a class to represent the request to get information. And so these classes may not have any data on them whatsoever. And you may look at it and say, well, gosh, isn't that kind of a waste? Because it's just a type with no information. But that class represents a concept, and that concept is requesting information. So in this case, this class represents the query for some index page. In this case, it may be the index page for people or invoices or orders. Whatever that might be, this represents that distinct and unique request for that data. One thing you also notice here is that I'm using inner classes to basically scope this request object. So instead of me having like generic reusable queries that can be used all across my system, I tried to not reuse as much as possible. And for us, actually, reuse was a 4-letter word. Even though it's 5 letters, some spelling, I guess. You can jam things together. Anyway, we tried as much as possible not to try to share logic between different handlers, to say, let's keep everything as distinct as possible. And using these inner types let us really represent that concept that these things really belong inside the scope of this one single page. Some of our queries could get a little more complicated. So if we needed to have some kind of parameterization going on with our queries, well, then these would just be additional properties on top of our query object. So this, for example, represents viewing some additional details for, I guess, like a course or something. And so all the different parameters that you might see in either the URL or any kind of parameters I'm pulling out of context, I'm just passing through as individual properties. And I try to capture all the data that the query handler needs in order to perform its work and put it in this individual query object. The idea is that if I want to know how does this query handler behave, what information does it need, I again just have this one single spot to go to see what the result is, or to see what the inputs are. Now, of course, my query does implement this interface, iRequest of t, and so this tells me what the response object looks like as well. So this query is a request that returns this other model class. So those two things are always going to be explicitly linked to each other. I will never have the case where a query could potentially return multiple response types. Each individual request only returns and only represents being able to get one kind of result. And again, it's just this avoid reuse as much as possible. We can do even more complicated things like paging and sorting and filtering, all the crazy things you can do with complicated search page, these again were all just properties I would put on my query object. And very oftentimes I could bind that query object directly to the request parameters to make my life a little bit easier. So now that I have my different query objects, my query requests modeled, I now turn my attention to the response objects. Now the response objects don't just live by themselves. Like none of my systems, I just take those responses and just directly give them to the end user as objects. They have to go through some sort of transformation. So typically, that response object is passed to something that then renders that information to the screen somehow. So for this example, let's just pretend like we're using classic MVC style architecture, and that response is then going to be passed directly to the view. So the idea is that the response object is artisanally crafted just for that one view and for nobody else. So I don't try to share responses. I make that view or whatever page it is only use that one single response object, and whatever I need to be able to render that screen, I have to have in that response. So it's a one-stop shop for all the data I could possibly need to be able to perform whatever thing I need to do to the final end user. In this case, rendering HTML. So some of our responses were simple. They just be like, here are some just dumb properties on there. And this is all the information that I need to show on the screen. You'll notice here that it's not connected to any kind of like domain object or entity framework thing or an Hibernate thing. It's not connected to any ORM. The idea is that everything that's necessary to be able to show that information is then captured in this object, and I don't have to go back out to anything else to be able to get data. Everything that I need is in this one single object. But things could get complicated. I could have like parent-child or like the parent information and then detail information. And so for those kinds of things, I could have this concept of an inner class again. So if I needed to show another list of information, instead of, again, me trying to share those classes and types outside, I explicitly modeled those as inner types so that it basically prevents us from trying to share those objects outside of the scope. There may be other pages in which I show similar information, but I want to guarantee that if I need to change this screen, I can change this class and not care about affecting anybody else. Before, when I had that layered architecture, we were very much sharing different methods and classes and types throughout our entire application. And so we kept having this problem that I needed to change some method in my repository, but that method's being used in 3 places. So I have to ask myself, well, do I need to like break it out into its own method? Do those other classes and other places that's using it also need this new change that I'm making? With this, I don't have to care about anybody else, really. This is like the selfish gene here, where it says I can just build whatever I need for my individual screen, and I don't care about anybody else. This is just what I need. Now, in some cases, we would see the commands and queries sort of linked together. And you can think of this in terms of viewing a form on a screen. So if I'm editing something or creating something, you initially have that first request, which is to show the form. Well, something needs to actually generate that HTML for the form, and so we'd have an initial query to be able to show that form. So we'd have this kind of duality in which a query's response type would actually be the command, and then the command would eventually be submitted back up through the form to actually do the work. So these things would kind of be chained together. I'd have a query to build out the command, which was the form, and then I'd submit the form again to then sort of rehydrate the command to actually perform the work. So you see this a lot in MVC applications where you have a get and a post that are doing, like the get is returning a view model, and then that same view model is going back into the post. This is the same kind of thing here, where the query's response is the command that I bind to the screen, and then finally I take that same object and push it back through in this request, the final request object here. So with my query inputs and outputs represented as these requests and objects, we then turn our attention to the commands. Now, commands are going to be a little bit different than the queries. The typical query requests don't have a lot of properties on them. But in our command requests, I need to have all the information necessary to perform the action on those request objects itself. So our request objects would include all the data necessary to be able to perform that action. And most typically, I could just look on the form on the screen and say, OK, I've got these input fields. So just take all these input fields and represent them as first-class properties on my command object. And then rely on whatever ASP.NET Core or whatever server-side framework necessary to be able to take those raw request variables and then bind them to this object to be able to be processed later on. I wanted to make sure, though, that whatever I needed to do to be able to perform this activity, whatever information I needed, had to be represented on this class itself. Well, oftentimes we saw that some of our kind of business logic would do some work, but then it'd reach out somewhere else, like, oh, I also need to know who the current user is. I need to know like what time it is. So we said, no, none of that. Everything you need has to be on this object so that we can effectively reason about what the work is actually doing behind the scenes. This is kind of hard for us because it's so easy just to be like, who's the current user? But it was difficult for us to reason about the behavior without understanding that this is all that's necessary to perform that work on this individual object. By the way, it starts to look very much like messaging, except this is in process. I will say, if you're doing this, this is all synchronous in process. Don't just take these and decide, I'm just going to throw them out into some kind of message bus or on a queue. You will have a very bad time, .gif or GIF. Because our interactions are really meant to be synchronous, so you just can't take these and say, we'll just make everything asynchronous, and the application will work just hunky-dory. So looking at these properties, these come directly from a form on the screen. So each of those properties I usually use to be able to build out this HTML as well. So I knew that this had an enrollment date because my form was, or the HTML was built based on that property existing. And so when it finally gets posted back up, it's all bound back together on the other side. Now, so far I know this application is not doing a whole lot. It's just like basically CRUD-based operations. Again, I'm not that creative with sample applications. I just steal from others. And so this is one of Microsoft's example that doesn't have all that complicated stuff. So let's pretend that we don't have just a simple CRUD application, and we have something that is doing more complicated work. And that more complicated work, instead of just having these kind of very simple CRUD-based operations associated, instead we'd have individual operations represented as tasks to do for the end user. So this one, for example, is my mock-up of a task-based UI for a student. So I can view the student details, but I also have the ability to transfer that student to a different course. I can correct some grading, or I can adjust their schedule to move some of their classes around. Now, each of these kinds of tasks and operations are very distinct from each other. So I try to represent every single unique thing you can do as individual requests, handlers, and responses in my system. So when I move towards this kind of vertical slice architecture, it fits really well with task-based UIs because I represent each of those individual requests as the tasks you can do on the screen, and every task as an individual request, and try to couple those two things as much as possible with each other. So I have transferring a student, I have correcting a student, and I have the scheduling of the student, and each of those requests is going to be distinct from each other. Each of those responses is going to be distinct from each other. And naturally, of course, the actual handling logic to do whatever is necessary to perform those operations, again, I'm going to keep those completely separate from each other as well. All right, so we've talked about the query requests, query responses, command requests. Next up are the command responses. And this is probably the most controversial part of this talk. Even though I've never done it before, I'm going to assume it's controversial. Because this part is a part that tends to fly against some of the traditional object-oriented advice people get. So most advice I hear about commands is that commands aren't supposed to return anything, which may be the case for a lot of our commands, that I just have some kind of request to go in to do something. The handler does this work, and they don't have any kind of response. But for a lot of our systems, we can't just stop with nothing. I'm like, OK, you did the thing, but like, what was the result of that thing? Did it succeed? Did it fail? Am I supposed to just look for exceptions? So we started representing the kind of result of the operation as some kind of individual result object. So these days, a lot of our commands actually do return something to tell the end user, like, and this was some result of your operation, so that we don't have to make like another request to say, okay, now what did you just do? Was that successful or not? The simplest approach would be to just represent the result of our operation as a simple true, false, success, or fail. So our requests implement this iRequest of bool, and then I return the result as like good or bad. Yes, it succeeded, or no, it did not. There could be some cases in which I need to know like some more details about what happened. So let's say I'm actually in this application creating something, like creating a student or creating an order. So I need to know some information about what just happened. So in this case, my response could be the ID of the thing that was created. So the handler, after it's done creating the object, will return back out the ID of whatever was created so that I can finally at the end say, okay, I've got the ID, then typically do some kind of redirect to say, okay, now here's the thing you just created. As opposed to just redirecting to the list of things, and it's left to the end user to figure out, wait, which one was the one I just created? Was it that one? No, we want to go like, okay, here's the one that you actually created. And we can only do that if we have the actual ID coming out the other side. Now we can get like way more complicated than this. If I need to have maybe more complex response types, and maybe I need to know not just that it was success or failed, but like why did it succeed or why did it fail? So we started to build more complex response objects, and we call these command results. These command results represented either a success or fail, but when it failed, I had to know what was the reason why it failed, and I can show that reason back to the end user. It could have a more complex payload. So now I have not just a response that's just a true or false, or just a failure reason or a GUID. Now I can put any kind of payload in there. So maybe it's the flattened out object. Maybe it's here's the main thing that you did, and here's all some other data as part of it. Now I have the ability to return back out some more pertinent information to the end user for what the operation they just performed. So for some of more complex applications that are doing more complicated work behind the scenes for their commands, then I start to represent the result of those commands as another kind of first-class citizen in our application. I would say don't start with this. It's tempting to say, let's just choose the most complicated end solution because you never know if we might need all this. But I tend to find it's easier just to start with the simplest thing that could possibly work, and then know that this thing exists so that you have a place to refactor towards if things do get complicated. I also don't like to have this as sort of a kind of a blanket response across my entire system because it annoys developers. I'm like, can I just return nothing? Like, nobody cares. I don't need to, no one's acting on this result. So I'd say only introduce this in the cases where you actually need to act on the result itself. So once I have the requests and the responses for both commands and queries modeled in my system, now I need to actually do some work. And this is like the thing I really want to focus on, which is handling these requests and the work that I find inside of them. First up, let's look at query handlers. Now again, the whole idea behind this is the work to be done for handling a query should be completely encapsulated inside of that handler. From the outside perspective, all I see is a request going in, some black box, and some response going out. So I have whatever tools necessary or whatever means at my disposal to be able to do whatever that work is. So it could be something as simple as using AutoMapper, because like I have to show this tool right. Like I'm not almost required to at this point. I'm using my preferred mode of using AutoMapper, which is to use link projections to be able to project straight out from my domain model directly out to a DTO. If you're using AutoMapper and you don't know about Project2, I would say please look it up, because if you get one thing out of this talk, it is if you're using AutoMapper, please do this. You will have the least amount of problems and least amount of headache if you just go this route. And what this is doing behind the scenes is converting the configuration of how to go from a source to a destination object into a link select projection. And ORMs know how to take that link select projection and translate that directly into SQL. So this is equivalent to a SQL view. where I have a predefined select statement to say select this directly into this DTO. So with projections, I completely skip any kind of intermediate rich domain model, and I go straight from SQL to DTO, except with this method, I don't have any kind of handcrafted, artisanal, bespoke SQL that I know we all love to write, right? So with this model, I go straight from that SQL straight to my object. But we can still do SQL if we want to. Like if we want to just drop down to using raw SQL for whatever reasons, maybe we want to show off that we know how to do cross-join the correct way, or we want to show people how to use common table expressions. Like you can still do SQL as long as if you want to. It's just fine. I would say if someone's forcing you to do store procedures, you could still do that. I'm sorry for you if you have to still do that. But from the outside perspective, I don't care what you do. Like just do whatever you need to take that request and then return some kind of response. So the handlers are intended to encapsulate all that sort of logic necessary to build a response. So it could be using EF core. I could be using Dapper. I could be using HTTP client. Maybe I have to call it to some other web API to be able to get that information. Maybe I have to go out to some kind of composed, crazy API gateway to get information. Maybe I have to take a bunch of different sources together to put something together. So maybe that's just some kind of like meat grinder that's just like churning a bunch of stuff together and then outputting a response. But the nice thing is, from my application's perspective, I don't care. All I see is a query, then some kind of black box that's going to handle the query, and then on the other side is my response. It's also possible in one application to have all of these different kinds of query handler approaches to my handlers. I would suggest maybe not do the meat grinder approach. Like if you have to do that, maybe try to simplify that. But it's certainly possible that I could use the correct tool for the job for each individual handler, which is shocking, I know. Use the correct tool for the job. Now there are cases that we do run into duplication. So I could have two different classes that have some kind of common query logic. And this is where I typically like pump the brakes with my teams to say, the first thing you should do whenever you see duplicated logic is to ask yourself, is it just accidentally duplicated? That it just looks the same just coincidentally? Or is it literally the same logic that needs to change at the same time for the same reasons forever and ever? So if we have that case that we know that this should be common shared logic, then we pull that common shared logic into something. What is that thing? Whatever you want. Could be a class, could be a function, could be an extension method, it could be another library. I don't really care. Just use the kind of standard refactoring techniques to pull that kind of common logic out. Queries are really the boring part, to be honest. Like it's just like get the data out as quickly and as efficiently as possible. But otherwise, it's queries. It's not that exciting. The interesting part, I think, comes into the command handlers, which is the real work happening in our system. So for our teams, what I like to do is just, again, a lot of my developers want to start off with the most complicated solution possible. But I really try to ground them in saying, just do the most boring thing that could possibly work. Imagine those old store procedures. Just do the most boring procedural code as possible. And if that's all you need to do, then just stop right there. Like if it's just 1 or 2 lines of code and it works, then just stop. That's OK. Well, a couple of things I do make sure that they do as developers. One, I want to make sure that we don't introduce any unnecessary abstractions. If that handler needs to use something, just use that thing directly. Don't introduce some kind of abstraction on top of it. So in this case, I don't have any kind of like repository on top of my DB context. I just use the DB context directly. Because I know that this logic is completely encapsulated from other handlers, then why do I need an abstraction? Why can't I just use all these things directly? I don't need to have that kind of indirection. It's not adding any value to my system. So anytime I saw any abstractions, I would reject the pull request. It never actually happened because we would tell them not to do it in the first place. But we made sure to just use all those things directly. And the only time I put in any kind of abstraction is really for testing purposes. So if I'm Building an application has to talk to SAP, boo. Then I want to put something in front of me, between me and it, because SAP is horrible to deal with, and it always goes down. So only in those cases where I want to isolate my system from others would I introduce some kind of abstraction. Otherwise, just use the real things and call it a day. I also find that the people that really hate dependency injection, they really hate abstractions that get enabled via dependency injection. For me, if my handlers are really small and stupid, my dependency injection configuration is also really small and stupid. So I don't really have any problem with it. Just like I have the request going in. If that handler needs other things to do its work, then those other things need to be passed in via dependency injection, and that's it. Now, sometimes these handlers can get really gnarly and ugly. And I tell my developers, like, just because we're using this pattern doesn't mean we have to be okay with ugly procedural code. So just don't panic. Remember that we can always go back to the old TDD mode of red, green, refactor. Although most people I know just stop at red and green and like move on to the next feature. But that last step is actually important. We need to look at the code that we just wrote, scrutinize it, and say, is there something we can do it to make it more easy to maintain over time? So at this point, I actually just fall back to the kind of 20 to 30-year-old techniques to make this kind of code better. We look at the different code smells I typically find there. So for these kind of handlers, I usually find that the class just got too big. And so the major code smells I'm looking at are going to be it's a large class and a long method. But there's a whole book written about how to fix this kind of code called refactoring, which I highly recommend. The second edition is out next year, but it's JavaScript oriented, so we'll see. And so there's just a standard set of refactorings that I can, based on the different code smells I see in a handler, decide how do I want to make this code easier to maintain over time. Typically, I'm using the last one there, compose method, which is basically take a really long method and break it up into smaller methods, all at the same conceptual level. Now, I won't go into an example of this because that would be a whole talk by itself on refactoring. But just know, like, just use the standard techniques of refactoring ugly code inside handlers. There's nothing that says if you're using this technique, you have to keep the code as ugly as possible. I also tend to find behavioral smells. And these are the kind of things that it's not just like the structural code looks ugly, but I also have some behavioral things that are going on. Things like I've got a lot of if-then statements. I've got a lot of complex conditionals going on. I've got duplicated code between different things. And so for that, I actually use another refactoring book. I know patterns, right? You're not supposed to use design patterns anymore. But I still find that they're useful in cases where I need to put some higher level abstractions or structures around the code I find in my handlers. There's not a whole lot of patterns I use these days. Once I go to this kind of approach, I basically have like decorator, chain of responsibility, and strategy. If I know those three patterns, that's like 99% of the pattern needs I have. And so really, I just look for the code smells that indicate that those patterns are, may need to be introduced, and introduce them when I feel they're necessary. What I really want to drive towards, though, is trying to push my behavior down. So right now, everything is procedural inside that handler. What I'd like to do is start pushing that behavior down into the domain model. So in this case, my handler now is just responsible for the kind of data access logic. This is a handler that's doing a create or edit. So the logic inside of there is, well, am I creating a new one or am I editing an existing one? Once I get that information about which is which, then I actually delegate all the actual behavior down to the domain model to do the real meat of the work. So down there, there's a handle method. And it says, now I've done the kind of data access junk. Now delegate out to the domain object to do the real meat of the work. So now the domain has the real work to be done. So in this case, I couldn't fit it on the screen because it was like 200 lines long, all this logic. But the general idea is that the real meat of the work you can start to push down into your individual domain objects. So now, instead of me having like these repository abstractions to facilitate unit testing, now I do actually have fully encapsulated domain models where all my behavior is. And you notice as well that I'm passing in my request objects all the way towards my models as well, my domain models as well, as opposed to trying to break it out into something else. So I don't really, in this case, I don't care if my domain model knows about the commands that need to act on the domain. That's really the only way I could really only way I could do this kind of pattern appropriately. So ideally, my domain green box grows with behavior, and that becomes really where all the work happens in my system. Now, before I do any work, typically I have to check to see, can you do that thing that you're trying to do? And so this comes into validation. So with this kind of architecture, I try to center my validation around the requests and the handlers. But I typically find that there are a couple different validation scopes that I have. There's the, just looking at the form itself, that request level validation. And then once I say, have you filled in all the junk on the screen? Okay, just make sure that maybe just a cat sat on your keyboard, but at least everything's filled in. I have that request level validation. And then I have the sort of second level domain validation, which is things like make sure that that email address isn't already taken when you're registering. Make sure that you can't ship a canceled order. Make sure that you can't add items to an order if it's already been accepted. That kind of validation can only really happen inside the domain model. So I have this command level validation that looks at not just the domain model state, but also looks at maybe other domain objects, maybe looks at the database, maybe has to go out to somewhere else. And inside of that is where I have the kind of second level of validation. So my requests can validate themselves. In this case, I'm using a tool called Fluent Validation, but you can certainly use any kind of data annotations is also a good fit for this one. The general idea, though, for this kind of validation, it can only look at that request object for this request validation. It can't go out to something else to see if it needs to be successful or not. It can only look at itself. So that constrains what I can do in here, but that's OK. I don't want to get too complicated in my request validation. I want to keep it separate between validating the request by itself versus looking at other things in the outside world to be able to say, is this request possible to do? The domain validation is where I can start leaning on those result objects. So in this one, for example, I'm trying to approve an invoice, and it will look to see what the status is. And if the status isn't a good status, it will just return back a failure reason saying, I can't do this, and this is why. So I've got my, now that I've validated the request, I got my response, the last little piece I want to talk about are some of the representations. That is taking that response and then putting it into the outside world. Now, in the original MVC way of working of things, when I went down this path and this architecture, my applications wind up looking something like this. That is, I had a controller with basically no behavior in it whatsoever. It was just like taking this request object and then delegating off to Mediatr to actually do the actual handling of the work. But the controller itself was almost pointless. It was basically just a description of routes. And then on the right-hand side, you can kind of see that I still have a little bit of disorganization. Like the controller contains stuff for everything, but then when I want to see the actual work being done, it's then split out into these other classes. These days, though, if I need to do server-side rendering, what I'll do is instead use Razor Pages, which fully encapsulates all the work necessary to be able to handle requests in one single place. So in this case, I've got a single Razor page that has the data to be shown on the screen. So that's that data property that has that model. It has the request and response objects. It has any kind of validation, configuration, handling. Everything necessary to be able to reason about this one request is in this one single spot. And then if I want to see how the thing is actually rendered, then of course the actual Razor CSHTML page is right next to it. So everything's right next to each other. That means that when my developers are developing in a system, they're only ever adding files. They're almost never editing files. And editing files and editing things is where we have merge conflicts and potentially bugs creeping in, because I'm changing code as opposed to adding code. So ideally, I'm only ever adding code, and by having everything encapsulated in one single spot for new requests, I can have a reasonable guarantee that I'm not breaking anything else. Now, web APIs are going to be a little bit different, because very often I'm sharing a lot of different actions for a thing on one single page application. So this one, for example, I've got different actions to perform on an order. I can approve an order, reject an order, hold an order, or cancel an order. each of those has their own individual handlers. However, if I'm looking at the browser, those are just buttons that are on the screen, but I don't leave that screen. So what typically happens is all of those handlers actually do return a common result object that is then passed into my single page application, hopefully React or Vue, and hopefully not Angular. And then my life is much better. So that one single response object is bound, again, to just one single view on the screen. So what I'm trying to get to here is a one-to-one with response objects and the representations. But sometimes the representations are shared against lots of different requests. And that's OK. So with all this in place, I still notice that when I go from handler to handler to handler, I may have some duplicated logic across a wide variety of different handlers. And so it's not enough for me to just say, well, let's extract all those pieces out into one class and have everything call it. I could have duplication that just basically stretches across all the different handlers in my system. So what I'd like to do is to say for every time you call this handler, also do this other behavior or this other logic. And so for us, we can use the decorator pattern in order to achieve this. I don't like to call it the decorator. It's kind of a weird name, so I called it pipeline behavior because some frameworks call them pipelines, some call them behaviors, so I just called it both. Why not? So these pipeline behaviors wrap the handler with additional logic, and I can then stack them as well. I can have additional pipeline behaviors all wrapping my one single handler. This is all still transparent to people using the handler. They don't necessarily know these other things are going on or don't have to worry about them, but it allows me to have cross-cutting concerns wrap around my individual handlers. So think this is similar to action filters in MVC, where filters wrap around the execution of an action. You can do additional behaviors. This is exactly what I have as well. I have a very simple interface that takes in the request object and then takes the next action to perform as a parameter, and I need to return back out the response. So let's say I want to have every single handler wrapped in a transaction. I can do that now with an additional behavior. This behavior takes in the original request object. It relies on the whatever ORM you want to use. In this case, it's Entity Framework. And then inside of the logic, it's going to say begin the transaction, call the next action, whatever that might be. It could be a handler. It could be another pipeline behavior. Commit the transaction. But if anything fails, so there's an exception, or perhaps I get some kind of validation failure, then go ahead and roll back the transaction. So with this pipeline behavior in place, I get to remove all of these save changes, method calls, and all of my handlers and say, you know what, that is taken care of for you. I could do something like a unit of work. Let's say I've got something like domain events, maybe. Something that needs to happen at the end of performing some logical operation. And so after I've done the work, I need to complete my unit of work. And I can do that pretty easily now with a pipeline behavior. What if things fail and I want to retry them? Well, now that's very easy for me to do. I can just have a simple while loop that says, try the action. And if it fails, just try it again. And if it fails some n number of times, OK, then go ahead and throw the exception. But if I have like, excuse me, if I'm using Azure, for example, like the Azure SQL always goes down. So they have it built in, like called over and over again. So we have a similar thing here that maybe I have concurrency problems, or I have the possibility of a lot of concurrency collisions. So I can just put in a retry policy in one place that says if I get that, if I get some kind of concurrency exception, just try the thing again, and then hopefully the thing resolves itself. Logging, of course, is like the canonical thing they do with decorators is log every single request. That's super simple now. I have one single place that I log every single request and response in my system. In this case, I log with a scope to say I'm starting this request. I'm going to call it to the handler. I do the work, and then when I'm done, I say, OK, this is what I called, and then this is the actual response on the other side. You may have to do something different in EU with the whole GPDR, GDPR, whatever. I don't have to worry about that kind of junk. So every single request and response then can be logged in the system, and if something fails for whatever reason, I have a record of that I've just enabled with this one single spot in my system. Registration is pretty easy for these sort of things. In my head, I think of them as the Russian dolls or the Matrushka, sure, the Russian dolls, where they're like, there's the meat in the middle that is my actual work, and then on top of it, I start to layer the other interesting behaviors in my system. But from the outside, I don't know about any of that. I just know I have a request, I'm sending in that request, it wraps everything in all those behaviors, calls a handler, and then out the other side is my response. Now the final part I want to talk about is testing. So looking at all these different things going on, I have a few different scopes of testing I want to look at. But overall, I can look at this set of work being done and see that basically this breaks down into, there's an arrange part, which is the request. There's the act, which is the middle junk. And then the assert, which is going to be looking at the response. So when I'm testing these kind of systems, I want to make sure that as much as possible I'm modeling the reality of how the system typically behaves. If I want to get confidence out of my tests, then they have to model as much as possible how the real world and how the real application actually works. So that means that when I set up my tests, it's going to set up the application very similarly to how my framework will set things up. But I'm not using that testing extension from ASP.NET Core because that's like sending raw HTTP requests in. That's like way too much for me. So instead what I'll be doing is basically just setting up all the dependencies and environments, but I'll still just be calling handlers themselves. Now there is some stuff that ASP.NET Core does for us. It executes everything inside scopes. So I want to mimic that kind of behavior in my tests. So I'll have these simple methods to say, execute something inside of a scope, then providing you a callback to say, okay, do something with the scope that you're working with. So I've got a couple methods here to say execute something inside of a scope, exactly like how every single ASP.NET Core request works. If I need to set up data, those will be also done inside of some kind of scope. So in this case, I'm passing in an action against the DB context. I will go ahead and get the DB context out, perform whatever action you need upon it, and then call save changes to make sure that all your changes are saved. I'll have a helper method now to send requests down as well. So this will rely on that previous execute scope method to be able to get out the Mediatr object, just like my Razor page or controller was doing, calling send to send the request down, and then that's all wrapped inside a scope, which means I have all of the pipeline behaviors and all the things that we're executing in the normal request pipeline of an ASP.NET Core application. I'm going to use a trick that I thought I'd never use, the C# 6 way of using static. So I'd say using static testing, which is all those test helper methods. And now I don't have to call like base fixture.send, instead of just have await send async and have a nice little helper method to be able to send out requests and to be able to get the response inside a test. My queries, I basically set up the data that I want. So I create a bunch of objects, say insert all those objects. Then in my test, I say send those objects down, get the response back out. And then my assertion is just look at the result object and make sure the result is what I expect. Now that does mean that inside my test, I will have multiple transactions and multiple scopes. That's okay. That's how the real system works. If I want to perform something in my application, I'm typically doing a series of actions and operations. So I don't want to do things like wrap everything in a transaction and roll it back at the end, because that will have some false positives. I want to use as much as possible how the real application actually works and behaves. So that means that I really want to set up my system through the front door and not through the back door. So in this case, my setup is also sending a command to do work. That ensures that it runs through all the validations, so I can't set up junk data. It performs all the side effects necessary. And I know that this is almost exactly like how an end user would actually use the system, but now it's represented as these first class operations in my test. I can't always do that. Sometimes I need to set up the data when necessary. So just like that's just a thing that happens in these kind of systems, that not everything I can do in the system is available as an action to perform through the user interface. So sometimes I do have to set up my own data. And then finally, looking at commands, when I test those, I will test them with actual round trips. So I'll say, do this work. It will do that work inside a scope transaction. And when I come back, I say, OK, now go ahead and get that information back out of the database and check to make sure that all the things were appropriately saved all the way down to the database and back out again. And so I have to go all the way back out. So that's that find async to say, go get the thing, pull it back out, and make sure it matches that original command I had before. So that means with this approach, I wind up having integration tests for every single request in my system. And for a lot of times, I can just go ahead and stop there. Like, if the handler is just doing all the work right inside the handler, there's no need to unit test it. If I've pushed down that behavior into my domain model, that's where my unit tests come into play. I unit test those things that are truly isolated and unit tests, and then integration test the things that I don't actually want to isolate and abstract. So, some key takeaways in vertical slice architecture. Vertical slices makes code super easy to add, change, and delete because I have that confidence to know that I'm changing one isolated part of my system and I'm not affecting anybody else. Do not skip the refactor step. A lot of people hate this architecture because they're like, my handlers are so ugly. It's because you didn't do that red-green refactor. You just did red-green. Or maybe you didn't have tests, so it was just like barfing in the keyboard, and it was done. So don't forget that refactor step. It is still important in these kinds of architectures. Try as much as possible to push your behavior down into the domain model so that the complicated logic is unit testable and you can get that quick feedback. And then finally, I recommend integration testing your handlers and unit testing your domain. Don't unit test your handlers. There's not really value in it. You want to mimic as much as possible how your real system behaves. And so that means integration tests. So that was vertical slice architecture. Say yes to celery and no to stinky onions, if that means anything to anyone. If you want sample code behind this, it's on my github.com/jbogard. There's some repositories with examples of this kind of code. Otherwise, thank you for your time, and I hope you have a great rest of the conference. Thank you.